Hello everyone. I'm going to talk about the factor theorem throughout this lesson. Factor theorem is actually extended from the remainder theorem. Remainder theorem was to tell us about what is the remainder if you divide by some kind of device. Okay. For this, well, the remainder can be anything. Can be 0, can be 2, -5, even it can be a mathematical expression. But for this factor theorem is where the remainder theorem gives us the remainder of 0. So then, then if you substitute a, then that is the factor. Have a think about this sort of long division, everyone. Okay, we're going to do a long division over here. We covered the long division already. So it just showing you the long division process here. So if you do the long division, okay, so x minus 2, we divide this polynomial by x minus 2. We came out here, that's the quotient, and that's the divisor. Well, what is the result? Yeah, that polynomial is divisible by x minus 2, and the result is that as a quotient, and remainder equal to 0. That therefore, what you can tell, x minus 2 is a factor, and then in this remainder theorem, which is substitute 2, it comes out as 0. So then we can also tell us about, or we can also tell about, x minus 2 is a factor. Okay, so whenever you find the factor, you do not have to do the long division in this case. Okay, you always try to find out by substituting proper numbers. Okay, and then whenever any specific number is giving a 0, then that is the factor. Okay, so we'll look at the question over here. Find the possible root of the polynomial px. Okay, so how you do? Well, you always look up the last number, which is the constant number. So list all of the factors of 24. So what are they? They including plus and minus. These are the factors. Okay, we are not going to tell they are all factors, but they are candidates of the factors. Okay, and then find the first factor of that. So what you're going to do, we're going to try to substitute one at a time to see whether that produces as a remainder of 0. Okay, that's the fact here. Substitute 1 here. Okay, so we're going to the first one, the plus 1. This be substitute to the px. It gives us 12. What do you want to tell? Yeah, this is not 0, so that is not a factor. So which means x minus 1 is not a factor. So that's what you have to tell. Okay. And then when you substitute -1, it also gives 30, which is not 0. So x plus 1 is not a factor. Okay? And then we substitute 2, it gives us 0. Yeah, it came out as a 0. So what do you want to tell? So x minus 2 is a factor. Okay, you keep on going. Okay, we luckily find out the first factor, which is giving 0 as a remainder. That's the factor. Good. Okay, we find the first factor. And the next one is factorize it completely. Okay, so how you do? Yeah, we know the x minus 2 is a factor, so we have to perform the long division in this case. Okay, so do the long division, guys. Firstly, that times what is x squared? It must be x squared. Okay, sorry. That times what is x cubed? That must be x squared. So multiply x squared for those two, and then make sure you subtract it. So x cubed disappeared, and minus 3x squared minus 2x, which is plus x squared, 2x squared, which is minus x squared, and write the rest over here. And then x minus what is minus x squared is minus x here. Okay, so multiply everything and make sure you subtract. So negative 10 minus 2x is actually negative 12x plus 24. Okay, again, lastly, x times what is negative 12x is negative 12. So multiply, we finally get 0 as a remainder. Therefore, we proved x minus 2. But if you don't have to prove it, say what the main purpose of doing this long division is to try to find the quotient. Okay, write the expression over here. So the px is multiple of the divisor, which is a factor in this case, times by the quotient. Okay, the question asks us to factorize it completely. So what you're going to do now? Yeah, we can factorize it again. Okay, so that is completely factorized. Understand it? So that's the usual process of the factor theorem. So yeah, it is not so surprising for you. So whenever you substitute any number of the candidate's factors pool as substitute, as long as it gives a zero remainder, that is a factor. Okay. Question 2. List the possible roots of this polynomial. Okay, it's slightly different situation. We have 12 leading coefficients here. So what you're going to do, list the candidate of the possible factors from 3 again here. Okay, it will be only 1 and 3, plus n minus 3, plus n minus 1. And then we need to also consider 12 here, okay? So what are the factors of 12, which is 1, 2, what is it? 3, 4, 6, and 12. Okay, so what you have to do now, well, one is there, okay? So you're going to divide that numbers by these numbers, so just one at a time. So what are you going to do? I'm going to divide everything by 2, okay? Divide by 2, divide by 2, come out here. And then next step is to divide by 3. So divide by 3, divide by 3. Next step is to divide by 4, divide by 6, and divide by 12, etc. So they are all possible roots. Okay, they're all candidates that can be some candidate of the real possible root. However, not all of them. You may be able to find some duplicates. So look at this one. Say 3 is same as 1, so we can ignore that. What else? Is there anything that you guys see any kind of duplicate over there? Say 3 on 6 is same as 1 on 2, so you can take that out. What else? 3 on 12 is same as 1 on 4, so you can take that out. Are they all gone, guys? So a third of yeah. So you can just take everything out. So we just list all of them. So they are really the possible candidate of the possible root in this case, guys. Yes, it's just to simplify and list the numbers as your preference order. So make sure you must be able to divide by the factors of the leading coefficient of the polynomial. So that's a little differentiation from the previous question. Question 2b, find the first factors. Okay, we list all of the possible factors again here. Just list the plus and minus, etc. everywhere. We try to substitute one at a time. Substitute 1, okay? It came out 10. Yeah, no, that is not. Okay, so 1 is not a factor, so just a takeout. So x minus 1 is not a factor over here. Minus 1. Okay, we have a minus 1. Substitute minus 1, it came out as 12. So that is not 0. So x plus 1 is not a factor for that. Okay. Now keep on going. Substitute 3. 360, no, that's not what we want. It's not a factor, so cross it out. Substitute negative 3, came out negative 210. No, this is not what we want. And we substitute a half. We substitute a half. Finally, we find the factor because remainder equal to 0. So x minus a half is a factor. Okay. Now, have a think about here, guys. So 12 equals to 4 times 3, also 2 times 6. Okay, so lots of combination in here. So again, same thing. X minus a half is a factor, does mean 2x minus 1 is a factor. Well, you don't have to keep this one because the fraction does cause some trouble. Okay, it's kind of inconveniences. So then we just multiply it by 2. Then you can get 2x minus 1 is a factor. So make it easy. So that's all I want to do. Like this one, okay? So 2 times 6 is a factor. Yeah, 2 and 6 are the factors. You times by 2, and then you divide by the rest. So it's just a balancing, okay? So I don't want you to divide x minus half. It's so complicated, guys, okay? And then part C, yeah, we're going to find factorize it completely. Okay, we factorize it completely. See here, say 2x divided by 2x minus 3 is much easier than you divide by x minus half. Oh, it's so horrible. Okay, I don't want you to do this one. Yeah, do a long division again, as we used to do, guys. Okay, 2x times what is 12x cubed? Yeah, you can easily find that must be 6x squared. Okay, so multiply everything. Yeah, just this is a tedious process for you. And times by 6 squared, so make sure you subtract them. It's gone. 8 minus 6, which becomes 14x squared, and write the rest. So 2x times what is 14x squared? Easily 7x. Okay, so multiply by 7x everywhere, and then make subtract. It's gone. So negative 13 minus negative 7 is negative 13 plus 6, or plus 7, which is negative 6x plus 3. Okay, and then 2x times what is negative 6x, which is negative 3. So multiply them, subtract them. Yeah, we conclude, yeah, the remainder equals 0 because 2x minus 1 also factor. Now, we're going to find the complete factorize over here. Okay, so write the polynomial is that times that. So we have over here, okay, so this times that. And then we can factorize this further. So do you know how to factorize? Yeah, you know, that's what we learned a long time ago. So that's the complete factorize, guys. Okay, so that is really the complete. So it's just a, you know, just a routinable processes, but only differentiation from question 1 and question 2 is showing the leading coefficient is not 1. So it's not monic, then you have to do a little more stuff to do. Okay, guys? Question 3. So question 3 tells us prove that the polynomial qx does not have an integer root. Integer root? Yeah, integer root is, in this case, what are the integer roots? We have only plus and minus 1 and 3. You're not going to divide by 4 or divide by 2 because they don't produce any integer root. Okay, so so only consider about that one. We try to substitute one at a time. Substitute 1 does not give you 0. Okay, so no, it doesn't produce any factor. Substitute negative 1, it does not produce any factor. Substitute 3, it does not produce any 0 because of all non-zero numbers. Lastly, if you substitute negative 3, it does not also produce 0 as well. So no, not at all. Therefore, that proves it does not have no integer root. You understand it? There are a few things, I guess, throughout performing the 3 questions. The first question, we just try to list all the possible roots by the looking at the constant number. In question 2, I covered the topic that there are some more extra factors. If the leading coefficient is not 1, you're going to divide everything by the factors of this one. Then you have a little more extra number of factors. Okay. Question 3, yeah, we just try to substitute any possible values. None of them produce any 0, then nothing. Okay, there's no integer root. That's what I covered throughout this lesson. Okay, so that was the factor theorem. I will see you at the next lesson, guys.